Morning students. Today we are going to see the diagonalization of a matrix in module 1. Already in last class we studied about the how to find the eigenvalue and eigenvector of the matrix. Similarly here also we are going to find the eigenvalue and eigenvector of the matrix. After that only we are going to find the diagonalization of the matrix. Okay. See the topic diagonalization of the matrix. D equal to n. What is the formula for diagonalization? Diagonalization formula is D equal to n transpose A n. D equal to n transpose A n. This is the formula. This is the formula for diagonalization. D equal to n transpose A n, where n is the normalized model matrix and A is the given matrix. So, see the problem. Diagonalize the matrix A equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. They are given the matrix. Diagonalize the matrix A equal to the given matrix is taken as A. Next, we have to check whether the given matrix is symmetric or not. So, how to check and A equal to row into column, the same matrix we are getting. So, A equal to A transpose, the given matrix is symmetric. Next, the characteristic equation we are going to find. What is the formula for characteristic equation? I think already all of you know the characteristic equation formula is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So, okay, first we are going to find the s1. What is s1? Sum of diagonals. S1 is sum of diagonals. Next, S2. What is S2? S2 is sum of the diagonals 8 plus 7 plus 3 we are getting 18. Next, sum of diagonal. S2 is minor of main diagonal. What is the minor of main diagonal? First you have to eliminate the first row and first column. Second you have to eliminate the plus value. Third you have to eliminate the last row and the last column. You are getting the value is 7 minus 3 minus 4 3 8 2 2 3 8 minus 6 minus 6 7. So adding these multiplication, cross multiplication, 7 into 3 is 21 minus 16 plus 8 into 3 is 24 minus 4 and 56 minus 36. You are adding these values, you are getting the answer is 45. Next S3. S3. How do you find S3? Easily you can find, use your calculator. Use your calculator. Go to the matrix mode and find, substitute all the values and find determinant of A. You can easily get the answer is 0. Need not to find in manual. Next, you are going to substitute all the value S1, S2, S3 in characteristic equation. This is the characteristic equation. Lambda cube minus 18 lambda square plus 45 lambda equal to 0. Next, to find what is the next step? Next step is you have to find the eigenvalue of the given matrix. Using your calculator, go to the degree mode and substitute all the values A, B, C and then D. A is 1, B is minus 18, C is 45, D is 0. You can easily get the answer is lambda 1 is 0, lambda 2 3 and lambda 3 is 15. But in your calculator they shown us x1, x2, x3. You have converted it as lambda 1, lambda 2, lambda 3. Next, to find the eigenvector. Next step is we have to find the eigenvector. How we can find the eigenvector? What is the formula for eigenvector? Modulus of A minus lambda I into x equal to 0. This is the formula for eigenvector. A is the given matrix and lambda is the eigenvalue. I is the identity matrix. X having the value x1, x2, x3. Okay, I am substituting all the values in the matrix. You are getting the equation is I. You are take this as capital I. This is the base of the, this is very important. This is the base of the for finding eigenvector. Next we are going to Deal three cases, case 1, case 2 and case 3. What is case 1? Case 1 is if the lambda having the value is 0. Lambda equal to 0. Next lambda having the value is 0. Next lambda, first case 1 we are substituting lambda equal to 0. If you are substituting lambda equal to 0 in I equation, see here case 1. Case 1, if lambda is having the value 0. 0. So I am substituting in the I equation. You are getting this matrix is 8 minus 6 2. Diagonal values only change and all the other value should not change. Next I am going to form the equation row into column. Row into column. Row into column, you are getting the first equation like this 8 into x1 minus 6 into x2 and 8 3 into 2 into x3. Similarly, you are going to form three different equations. Next, you are going to see whether the three equations are same or different. And see, check whether the three equations same or different. All the three equations are different. So, we are going to use cross multiplication rule. First, this is the first, I am taking the first equation and the second equation. First equation start with x2, middle value, that is x2 minus 6 and here minus 2 and the 8. Next one is minus. Start and ending with the same value. Similarly, for second equation 7 minus 4 and then x minus 6 and then 7. Sorry, this is plus 7. Next, I'm going to cross multiply this. 6 minus 6 into minus 4, 24 minus 7 2s are 14. Similarly, 12 plus 32, here 56 minus 36. So, you are getting the answer is x1 divided by 20, x2 divided by 20, x3 divided by 20. So, I'm going to divide by 10. You can easily chart out the answer x1 having 1 2 2. Similarly, you are going to find all the other cases. What is case 2? See here. Case 2. What is case 2? Case 2 is lambda having the value is 3. Lambda having the value is 3. I am going to substitute lambda equal to 3 in the base equation. You are getting the answer as that is 5 minus 6 2 and minus 6 4 minus 4 and minus 2 0. Next same here also we are going to follow the row into column. The 5x1 minus 6x2 plus 2x3. Similarly second equation and third equation. Here also the same here. Here the equations are different. Use cross multiplication rule. So, cross multiplication rule you are going to use. You can take any two of the equations. Okay. When the equations are same, you have to substitute x1 equal to 0 and find all other two values. If it is the equation is different, you have to use cross multiplication rule. So, x1 the same here also. 24 minus 8 minus 12 plus 20 and then 20 minus 36. You are getting the answer as x1 by 16, 8 and minus 16. You can divide by 8. You can get the answer. Simplify the eigenvector. So, x2 divided by 2, 1 minus 2. Similarly, case 3. See here, case 3. What is case 3? Lambda 3 equal to 15. Now, you are going to substitute lambda 3 equal to 15 in that I base equation, that is I. Okay. You are getting the matrix like this. The same we are going to repeat it. Minus 7x1 minus 6x2 plus 2x3. The first equation and second equation, third equation. Here also same. The equations are different. So, we are going to use cross multiplication rule. 6 into minus 4. 24 plus 16 and minus 12 minus 28, 56 minus 36. You are getting the final answer is x1 is 40, x1 is 40 and minus 40 and 20. You can divide by 20. You are getting the simplified eigenvector is 2 minus 2 1. So now we find that eigenvectors, that is capital X1, capital X2 and capital X3. Next we are going to diagonalize the matrix. Already I told what is the formula for diagonalization? D equal to n transpose an. Before that, the one step is very important. That is you have to check the orthogonal condition. Check the orthogonal because the given matrix is symmetric. You have to check the orthogonal condition. So x1 transpose x2 equal to 0 and x2 transpose x3 0 and x3 transpose x1 equal to 0. Okay, I am going to substitute the x1 as a transpose. That means row into column. Sorry, column into row. 1, 2, 2 and 2, 1 minus 2. You are multiplying this row into column. 2 plus 2 minus 4 equal to. Similarly, x2 transposes row column becomes row and multiplying this you are getting the answer is 0. Similarly, x3 transpose row and then column you are multiplying this you are getting 0. If all the values are 0, then only your eigenvector is correct. The eigenvector is correct. Otherwise, you have to check whether the eigenvector is correct or not. Next, the orthogonal condition is satisfied. Then we move on to the diagonalization. See, diagonalization formula already you know D equal to n transpose an. What is D? D is the diagonalization. N is the normalized model matrix. N is the normalized model matrix. We are going to form the normalized model matrix using the eigenvectors. Okay, see here. What is the n? Here, what is x1 we got? That is x1 equal to, what is capital X1 first eigenvector? X1 equal to 1, 2, 2 and x2 equal to 2, 1 minus 2 and x3 equal to 2 minus 2, 1. Using these eigenvectors, we are going to form the normalized model matrix. First, we are taking the first eigenvector, that is 1. 1 divided by the square root of all the values. Root of 1 square plus 2 square plus 2 square. This is the denominator. Both the denominator in column 1 are same. Here are same. Okay, all of you understand? This is the first x1 you are taking. Next, for the second column, you are going to take the second eigenvector, that is x2. See here, 2, 1 minus 2. So, first 2 divided by the square root of all the values. Root of 2 square, 1 square plus minus 2 the whole square. So, you are getting this answer here. And here also same, here also same. Next, the third vector you are going to take, third column you are going to take the third eigenvector, that is x3. x3 is 2 minus 1. See here, x3 is 2 minus 2, 1. So, I am going to use here, that is 2 divided by square root of 2 square plus minus 2 square plus 1 square. The denominators are same. Next, we are going to, you are simplifying this, you are getting the value for n is, you are getting root 9. Root 9 is 3. So 1 by 3, 1 by 3, 2 by 3, 2 by 3 and 2 by 3, 1 by 3 minus 2 by 3 minus 2 by 3, 1 by 3. Now next we are going to find n transpose, that is row becomes columns. Okay. Next we have formed n transpose. Next, finally we are substituting all the values, that is n transpose A is given matrix n in diagonalization. D equal to, this is n transpose, this is A, this is n. Finally, you are multiplying all these three terms using your calculator. You have to multiply all the three matrices. Finally, you are getting capital D equal to the triangular matrix. This is the diagonalization. See here, you can find here the eigenvalue. What is the eigenvalue? Lambda 1 equal to 0, lambda 2 equal to 3 and lambda 3 equal to 15. This is the eigenvalues appear in the diagonal form and all the other values are 0. This is the diagonalization. Thank you.